Research by University of Massachusetts. Amherst scientists provides a new answer to one of the persistent questions in historical climatology, environmental history, and the earth sciences. What caused the Little Ice Age? The answer we now know is a paradox: warming. The Little Ice Age was one of the coldest periods of the past 10,000 years, a period of cooling that was particularly pronounced in the North Atlantic region. This cold spell, whose precise timeline scientists debate, but which seems to have set in around 600 years ago, was responsible for crop failures, famines, and pandemics throughout Europe, resulting in misery and death for millions. To date, the mechanisms that led to this harsh climate state have remained inconclusive. Now, U.S. National Science Foundation-funded research results published in Science Advances give an up-to-date picture of the events that brought about the Little Ice Age. Surprisingly, the cooling appears to have been triggered by an unusually warm episode. When climatologists began carefully examining their reconstruction of North Atlantic sea surface temperatures, they noticed something surprising: a sudden change from very warm conditions in the late 1300s to unprecedented cold conditions in the early 1400s, only 20 years later. Using detailed marine records, scientists discovered that there was an abnormally strong northward transfer of warm water in the late 1300s, which peaked around 1380. As a result, the waters south of Greenland and the Nordic seas became much warmer than usual. No one had recognized this before. Normally, there is a transfer of warm water from the tropics to the Arctic. It's a well-known process called the Atlantic Meridional Overturning Circulation, or AMOC, which is like a planetary conveyor belt. Typically, warm water from the tropics flows north along the coast of northern Europe, and when it reaches higher latitudes and meets colder Arctic waters, it loses heat and becomes denser, causing the water to sink to the bottom of the ocean. This deep water formation then flows south along the coast of North America and continues to circulate around the world. But in the late 1300s, the AMOC strengthened significantly, which meant that far more warm water than usual was moving north, resulting in rapid Arctic ice loss. Over the course of a few decades spanning the late 1300s to early 1400s, vast amounts of ice were flushed out into the North Atlantic, which not only cooled the North Atlantic waters, but also diluted their saltiness, ultimately causing the AMOC to collapse. It is this collapse that then triggered a substantial cooling. The Gulf Stream plays a crucial role in regulating the climate of Western Europe, where its warm waters help moderate temperatures, particularly in the winter months. As the devastating impacts of climate change unfold, one of its most ominous manifestations is the accelerating meltdown of glaciers worldwide. These icy behemoths, once thought to be eternal, are now succumbing to the relentless onslaught of rising global temperatures. And that could spell trouble for the entire planet, according to an old study that is again gaining traction. It says that the Gulf Stream could collapse due to melting glaciers as soon as 2025, shutting down vital ocean currents. The Gulf Stream, a powerful ocean current originating in the Gulf of Mexico, plays a pivotal role in regulating the climate of the North Atlantic region. Its warm waters act as a natural conveyor belt, transporting heat from the equator toward the poles and influencing weather patterns along its path. Without this additional heat, the average temperature could drop by several degrees in North America, parts of Asia, and Europe, as much as 10 degrees Celsius in a few decades. This will have severe and cascading consequences around the world. These include increase in storms, severe disruption in rain that billions of people depend on for food, and a rise in sea level on the eastern coast of North America. a scenario similar to what was shown in the 2004 film The Day After Tomorrow. According to The Guardian, the study estimates a timescale for the collapse of the Gulf Stream between 2025 and 2095, with a central estimate of 2050 if global carbon emissions are not reduced. I think we should be very worried. This would be a very, very large change. The AMOC has not been shut off for 12,000 years, said Professor Peter Ditlevsen at the University of Copenhagen in Denmark, who led the new study. The Gulf Stream is part of a much wider system of currents, officially called the Atlantic Meridional Overturning Circulation, or AMOC. The study, published in the journal Nature Communications, used sea surface temperature data stretching back to 1870, when the Little Ice Age ended, as a proxy for the change in strength of ocean currents over time. The researchers then mapped this data onto the path seen in systems that are approaching a particular type of tipping point called a saddle node bifurcation. The data fitted surprisingly well, said Professor Ditlevsen. The Gulf Stream plays a crucial role in regulating the climate of Western Europe, where its warm waters help moderate temperatures, particularly in the winter months. A slowdown or disruption of this current could lead to more extreme weather events, including colder winters and hotter summers, with potentially devastating consequences for agriculture, infrastructure, and public health. Thank you for watching the Cosmos News YouTube channel. If you enjoyed this video, please give it a thumbs up, share it with your friends, and don't forget to subscribe to our channel for more exciting content like this. Your support means the world to us, and remember, keep looking up at the stars. Until next time, stay curious and keep exploring. Thank you again.